For over 50 years, India has been planning two of its boldest infrastructure ideas, projects so ambitious that engineers are attempting to reshape the geography of the subcontinent itself. The first begins on the coast of Gujarat, a 60-kilometer dam, not across a river or a lake, but across a vast arm of the ocean itself. This is the Kalpasar Project. Surat and Bhavnagar are two of Gujarat's most important cities. Both are major centers of trade, industry, and economic activity, and on a map, they appear remarkably close, less than 100 kilometers apart in a straight line. But there is one enormous obstacle between them, the Gulf of Khambhat. As a result, traveling between Surat and Bhavnagar currently means taking a long detour around the Gulf, turning what should be a short journey into several hours on the road. For decades, this geography has kept the two cities far more disconnected than their actual distance suggests. A direct crossing could dramatically reduce travel time, improve the movement of goods and people, and create a new economic corridor connecting some of Gujarat's most productive regions. Every vehicle that travels between South Gujarat and Saurashtra has to travel 350 kilometers. Every day, lakhs of vehicles burn extra fuel making this detour. Every freight train connecting Saurashtra to the rest of Gujarat goes via the Vadodara-Ahmedabad-Surendranagar loop, adding hours to every journey. The inefficiency embedded in the geography of Gujarat has been costing the state and the country enormous amounts in wasted time and fuel for as long as anyone can remember. For 50 years, the Gujarat government has been planning a solution, not a longer road or a better detour, but a 60-kilometer dam straight across the Gulf of Khambhat, sealing off an arm of the Arabian Sea, converting it from saltwater to freshwater, and building a 16-lane highway and 4-lane railway directly across it. Kalpasar Project is the most audacious water infrastructure project any Indian state has ever conceived, the largest freshwater reservoir India has ever attempted to create. And in May 2026, for the first time, it started moving toward reality. But why now? Because the project received a major push after Prime Minister Narendra Modi's official visit to the Netherlands in May 2026. PM Modi secured a dedicated India-Netherlands agreement for technical cooperation on Gujarat's Kalpasar project. The revised cost now stands at 1,33,000 crore rupees. After half a century on the drawing board, Gujarat has decided that 50 years of planning is enough, and this project must now move from paper to the sea. By the end of the video, you will understand why this project will be one of the most remarkable acts of engineering in human history. The Gulf that divides Gujarat. The Gulf of Khambhat is not a small body of water. It is a large, deep, funnel-shaped arm of the Arabian Sea that cuts approximately 200 kilometers into the Gujarat coastline, separating the Saurashtra Peninsula from much of south and central Gujarat. Because the Gulf is shaped like a funnel, the tidal water that enters from the Arabian Sea has nowhere to go but up as it moves north. The result is a tidal range of up to 11 meters. Most coastlines around the world experience tidal ranges of 1 to 3 meters. The Gulf of Khambhat's tides are 4 to 11 times higher. The water rushes in and out twice daily with enormous force, carrying massive loads of silt and generating currents that have made the Gulf one of the most challenging marine environments for construction. These tidal dynamics have historically made the Gulf almost impossible to bridge, dam, or develop. The same tides that make Kalpasar technically difficult also make it potentially valuable. A tidal range of 11 meters represents enormous energy that could theoretically be harnessed for tidal power generation. The Sabarmati, the Mahi, the Narmada, and the Dadar are among the rivers that flow into the Gulf of Khambhat. These rivers carry much of Gujarat's fresh water into the sea, where it is lost. What India is actually planning to build. The Kalpasar project will have several connected parts. The proposed dam would not only stop seawater, its wide top is also planned to carry a 16-lane highway and 4 railway lines. The dam would separate part of the Gulf of Khambhat from the sea. Over time, fresh water flowing in from nearby rivers would replace much of the salt water and create a huge freshwater reservoir. The reservoir is expected to store billions of cubic meters of water. This could provide drinking water and irrigation to Saurashtra, one of Gujarat's driest regions. Farmers there depend heavily on uncertain rainfall and shrinking groundwater supplies. A large reservoir could greatly improve water security for the region. The project also includes 5 lift irrigation schemes designed to carry water to drought-prone districts. Along with this, it plans major road and rail upgrades at both ends of the dam corridor. It also includes tidal power systems that could use the Gulf of Khambhat's powerful tides to generate electricity. Beyond that, new industrial development zones are planned to benefit from better transport, water access, and connectivity. Taken together, Kalpasar is not simply a water project with some transport benefits. It is a much larger plan to transform the entire region around one massive dam. The engineering that makes it extraordinarily difficult. The tidal problem is the primary challenge here. A tidal range of 11 meters means that the sea level on one side of the dam will rise and fall by 11 meters, twice every day, indefinitely. Every tide cycle exerts pressure on the structure, generates currents at the base of the dam, and deposits sediment in ways that standard dam designs are not built to manage. The Gujarat coastline is also seismically active. The 2001 Bhuj earthquake, magnitude 7.7, causing over 20,000 deaths and enormous structural damage across the state, was generated by the seismic faults running through this region. A 60-kilometer dam built across a seismically active marine zone must be engineered to survive the earthquakes that are possible in this region. During an earthquake, the wet soil beneath the dam could weaken and lose its ability to support the structure. The cyclone problem adds a third dimension. The Arabian Sea cyclone season produces enormous storms. The Gujarat coast has historically been exposed to cyclones of significant intensity. The Kalpasar Dam, 60 kilometers of structure exposed to the open sea on its western face, must be designed to withstand the worst weather the Arabian Sea can produce. This is not a theoretical requirement. It is a design constraint that affects every structural element of the project. It is precisely these challenges that explain why the Kalpasar project has been on paper for years. It is not that the concept is unclear or that the need is uncertain. It is that the combination of tidal forces, seismic exposure, and cyclonic weather creates an engineering problem for which there is no direct precedent at this scale. The Dutch did something comparable, but in a far less hostile marine environment, at roughly half the length. India is attempting Kalpasar at twice the scale of the Dutch achievement, in conditions the Dutch never faced. The Dutch built the Afsluitdijk in the early 20th century using technologies and methods that were, at the time, genuinely at the frontier of what was possible. The dam is 32 kilometers long. It was built across a relatively shallow inland sea with a maximum tidal range of about 1.5 to 2 meters. The Jaisalmer Lake it created behind the dam now provides significant freshwater storage for the Netherlands and has been the foundation of large-scale land reclamation that expanded the Netherlands' usable territory significantly. In May 2026, when Prime Minister Modi visited the Netherlands and signed a letter of intent for Dutch technical cooperation on Kalpasar, the Dutch government brought the engineering knowledge of the Afsluitdijk and the newer Maaslandkering storm surge barrier to the table. The Dutch have spent a century advancing marine engineering, building increasingly sophisticated barriers, surge gates, and flood control systems. But even Dutch engineers acknowledge that Kalpasar's tidal range and seismic exposure represent challenges. The cooperation is valuable, but the problems remain extraordinary. The rivers that would supply water to the Kalpasar reservoir have one major advantage. They begin and flow entirely within India. The Sabarmati starts in the Aravalli Hills, the Mahi begins in Madhya Pradesh, and the Narmada also rises in Madhya Pradesh. None of these rivers enter India from another country. This means their water supply does not depend on agreements, political relations, or decisions made by a foreign government. India would not have to worry about another country reducing or controlling the flow. The water comes from within India, flows through Indian territory, and can be managed entirely by India. For a project as important as Kalpasar, that gives the country much greater control and long-term security over its water supply. Today, water is becoming an important geopolitical issue. Countries located upstream can control how much river water flows into countries below them, sometimes using that control to protect their own interests. Kalpasar would be different. Its proposed freshwater reservoir would sit entirely within India and would be filled by rivers that also originate inside the country. That means the water could not be reduced, blocked, or controlled by another nation. Beyond supporting farms and providing drinking water, the reservoir would also give India a large and secure water reserve under its own control. As climate change increases rainfall variability and as geopolitical tensions around water access intensify, that strategic independence becomes more valuable with each passing decade. The land reclamation potential is a further possibility. The Kalpasar Reservoir, depending on its final water management strategy, could potentially add new land to Gujarat's territory from what is currently the ocean floor. India's second great water project approaches scarcity in a completely different way. Kalpasar aims to create fresh water by separating part of the sea. The second project does not create new fresh water. Instead, it plans to move existing river water from a region that has more than it needs to one that has far too little. This project is the opening chapter of India's National Perspective Plan for River Interlinking, a century-old ambition to connect 30 river basins across the country so that water surplus rivers can share their surplus with water deficit regions. This is the Ken-Betwa River Linking Project. Two rivers, the Ken and the Betwa, that have flowed independently for millions of years, are now being connected by human engineering for the first time. Ken-Betwa is the proof of concept. If this works, if the dam is built, the canal is dug, the water moves from the Ken Basin to the Betwa Basin, and the farms of Bundelkhand receive the irrigation they have been waiting for, then the case for the next 30 interlinking projects becomes immensely stronger. If it does not work, if the environmental cost is too high, the technical challenges prove too great, or the social displacement is too severe, then the broader program faces serious questions. The stakes, therefore, are not limited to Bundelkhand. Ken-Betwa is the test case for an idea that could reshape the water geography of the entire Indian subcontinent. Bundelkhand is one of the most water-stressed regions in India, even though several rivers flow through and around it. The Ken River passes through the region. The Betwa River runs along its border, while the Sun River drains its eastern side. But much of Bundelkhand lies on hard, rocky land that does not store water easily. Most of its rain also falls within a few months, followed by long dry periods. As a result, many farmers living near these rivers still do not have a reliable supply of water for their fields. The consequences of this water crisis have been devastating. Bundelkhand has recorded one of the highest rates of farmer suicides in India. Every summer, drought and crop failure force families to leave their villages and travel to distant cities for construction work. Not because they want to leave, but because there is no longer enough to survive on at home. During severe droughts, children are pulled out of school. Women spend hours walking in search of shrinking water sources. Farmers live beside rivers, but still cannot depend on enough water for their fields. That is the tragedy of Bundelkhand. Water exists all around the region, but for millions of people, it remains out of reach. The 13 districts of Bundelkhand that the Ken-Betwa link is designed to serve span 4 of them in Uttar Pradesh and 9 in Madhya Pradesh. The common thread across all 13 is the same story in different intensities. Agriculture dependent on rainfall that is increasingly unreliable, groundwater that is depleting faster than it recharges, and a population caught between staying on drought-prone land and the difficult alternative of leaving the only home they have ever known. The Ken-Betwa link is mainly meant to help Bundelkhand's farmers. It would bring reliable irrigation to fields growing wheat, cotton, and pulses, crops that currently depend heavily on the monsoon. For farmers, this could replace uncertainty with a steady water supply. And that would not only improve incomes, it could also reduce one of the biggest causes of hardship in Bundelkhand. The Ken-Betwa River Link project is structured in 2 phases. Phase 1 is the centerpiece and the most challenging component. It covers the construction of the Dowden Dam on the Ken River, 2 tunnels, 2 powerhouses, one at the dam toe and one at the outlet of the lower level tunnel, and the 218-kilometer link canal connecting the Ken and Betwa basins. This canal carries water from the Ken's reservoir to the agricultural plains of both Madhya Pradesh and Uttar Pradesh. Phase 2 would add more water infrastructure, including the Lower Ore Dam on the Ore River, the Bina Complex Project on the Bina River, and the Kotha Barrage. These projects would bring water to more drought-affected parts of Bundelkhand. The project received approval, and Prime Minister Narendra Modi later laid the foundation stone in Khajuraho. Since then, work has begun at the dam site in Chhatarpur. The land is being prepared, excavation has started, and the river will be redirected so the main structure can be built safely. This matters because India has seen many large projects get announced with great excitement, only to slow down before real construction begins. Ken-Betwa has crossed that difficult stage. It is no longer only a plan on paper. Machines are on the ground, workers are at the site, and the dam is being built. The challenge now is to keep the work moving. Large projects can change millions of lives, but they can also deeply affect the people living closest to them. The Dowden Dam Reservoir will cover village land and force many families to leave their homes, farms, and communities. Some families have already been moved to new settlements. On paper, resettlement may include compensation, housing, and basic facilities. But starting life again in a new place is never simple. Families have reported problems such as unreliable water supply, expensive water tankers, long distances from ration shops and government services, fewer work opportunities, and disruption to children's education. A farmer may receive money for land, but money cannot immediately replace years of knowledge about the soil, nearby markets, family support, and community relationships. Some tribal communities near the project have also protested over compensation, resettlement conditions, and the loss of access to forests. These concerns should not be ignored. Real development should not only complete a dam, it should also protect the dignity of the people who make way for it. The Dowden Dam is another controversial element of this project. The dam is being constructed on the Ken River approximately 2.5 kilometers upstream of the existing Ganga Weir in Chhatarpur district, Madhya Pradesh. The problem is where it sits. The Dowden Dam is being built inside the Panna Tiger Reserve. The reservoir it creates will submerge approximately 98 square kilometers of the reserve, an area of forest that provides core habitat for one of India's most carefully managed tiger populations, nesting grounds for critically endangered vultures, and breeding habitat for the critically endangered gharial, which exists in significant numbers only in a handful of Indian rivers and whose survival depends on the specific rocky riverbank habitat of the Ken. The history of Panna Tiger Reserve adds a specific poignancy to this controversy. In 2009, the reserve was found to have lost all its tigers, a result of poaching. What followed was one of India's most ambitious wildlife recovery operations. Tigers were translocated from other reserves, strict protection was enforced, and Panna's tiger population was rebuilt from zero. By 2026, Panna's tiger count had recovered to over 60 individuals, a genuine conservation success story that had become a model for tiger management globally. The government's position is that the benefits of providing water to 62 lakh people in one of India's most water-stressed regions outweigh the environmental cost of submerging 98 square kilometers of forest. But it is a position that requires acknowledging, clearly and honestly, what is being lost in order to gain what the project promises. Ken-Betwa is important because it is the first major step in India's larger plan to connect rivers and move water from places with more supply to places that regularly face shortages. The basic idea is easy to understand. India receives plenty of rain overall, but it does not fall equally across the country. Some regions face floods, while others struggle with drought. The river linking plan tries to reduce this imbalance by using dams and canals to move water where it is needed most. Other proposed river links could eventually help dry regions in western, central, eastern, and southern India. But all of them will face difficult questions involving states, forests, wildlife, land, and local communities. Whether those projects move forward may depend heavily on what happens at Ken-Betwa. Kalpasar and Ken-Betwa are very different projects. One faces the ocean, the other connects rivers, but both come from the same belief. India should not remain helpless in front of unequal water distribution. For decades, farmers have depended on uncertain rainfall. Villages have watched groundwater levels fall. Families have migrated because agriculture could no longer support them. Governments prepared reports, held meetings, and announced new timelines, but construction kept moving further into the future. Now, that is beginning to change. Work is underway at the Dowden Dam site. Kalpasar has again entered serious planning with international engineering support. Projects that remain trapped in files for decades are finally moving closer to reality. That deserves appreciation. India is not a country lacking ideas. It has always produced bold plans, skilled engineers, and the ability to solve difficult problems. These projects show a country becoming more willing to take on difficult work and build infrastructure for future generations. There will be environmental concerns. There will be displacement. There will be delays, criticism, and difficult choices. Those questions must be taken seriously. But India should also receive credit for attempting solutions at such scale. A nation with more than 1 billion people cannot solve water stress through small steps alone. It needs careful planning, responsible construction, and the courage to build projects that may take decades to fully prove their value. Kalpasar and Ken-Betwa are not simply dams and canals. They represent a larger change in India's mindset. If you enjoyed this video, share it with someone who would love to see how India is turning its biggest ideas into reality. Subscribe for more documentaries on the projects shaping the country's future. Thank you for watching, and we will see you in the next one.